Hi everybody, I want to prepare you a little bit for the next quiz, which is where I'm going to ask you to do rather simple algorithm. First of all, describe the algorithm in words, tell me what you're going to do. Somehow, it doesn't have to be very detailed, but somehow to have an idea of what you're doing. It's also important for yourself to know what you're going to do, because you then, the second part, you're going to have to implement it into pseudocode. And that's, you cannot write pseudocode just like that. You have to first think about what am I going to do. So I'm going to take two problems. The first problem is about a palindrome. So let me first remind you what a palindrome is if you don't remember, if you don't know. A palindrome is a word that's the same read forward as backward. So word same if read backwards. And the English language has a lot of palindromes, but when we say word, we don't necessarily mean an English word. What we actually really mean is a bunch of letters. So an example of a real palindrome would be mom, right? If you read it from left to right or from right to left, it's the same word. Noon, sorry. A longer one, you want to see a long one? Race car. That's a nice one, right? Backward or forward, it's the same. Notice that some of them odd, some have even numbers, okay? But for us also, this is a palindrome, KLXLK, because forward and backwards is the same thing. So when we talk about palindromes and words, in this kind of problems, we don't really mean to say literally English words, but we mean any combination of strings where if you go to the string from left to right or go from right to left, you get the same string of letters. So what we need is a procedure. I'm going to already give it a name. Why is it doing this? Sometimes it keeps doing this, and it's because I push something. I don't know. Procedure, and let's call it palindrome. And the procedure will consist of two lists, words if you want, but I'm gonna consider this to, consists of one list, of course. One list, A1 only N, so these are I's are letters. In fact, they don't have to be letters, they could be anything, and a palindrome would be then a list that is the same when you go from left to right or from right to left. Okay, and what I want is, so goal, check whether a given input which would be a string of letters, is a palindrome. That's the goal. So, if I give you a string like that, like say this string here, how do you check that it is a palindrome? Well, it means, for one thing, what does it mean? If it has to be the same from left to right and from right to left, it means the first and the last letter should be the same, right? So, that one thing I should check is that these two letters are the same. So, check first and last are the same. Then, well, you can do some things. You can either remove them from the list and do the same thing. Then compare second and second last. And we keep and go on and continue until all letters are checked. Okay? That's not so bad, right? That's what you would do. Now, it's slightly different when you write it down than the actual implementation. Now we have to think a little bit about implementation. How are we going to implement that? For one thing, we're going to have to loop through the list, right? We're going to have to go to the first element, but at the same time also look at the last element. These are not separate loops, by the way. There's one and the same loop. At each instance of this loop, I will look at like say in the second instance of this loop, I will look at the second and the second last. So I will look at these two. So at each instance, I will look at two different letters and then compare them. That's my goal. Okay, so that means there should be a loop. And a loop, I should loop over all the letters. Now, if you think a little bit about that particular question, you would actually only, if you would do it by hand, so to speak, you would say, okay, the case checks, the else check, there's only one X, so it checks, so yes. In other words, you don't go through the whole word, you go to halfway the word, right? The same for race car, okay? R's and R's, A's and A's, C's and C's, and then there's just an E left. Or here, N and N, O and O. If you check everything and there's nothing left, then you stop. Could think, okay, I want to implement that as part of the whole problem. But when we talk about complexity and how efficient algorithms are, it will kind of become clear that it doesn't really make that much a difference. Instead of going only halfway, I could go to the whole list anyway, right? If I look at the first, I'm going to look at the fourth letter. So let's do this step 4. In step 4, let me write it over here again. So K, L, X, L, K, and I'm looking at the fourth letter in the list. That's the fourth letter in the list, and also the fourth last letter of the list. So there's 1, 2, 3, 4. That would be this one, and I compare them. It matches. If it's a palindrome, it should match. So there's no loss in going to the whole list. Okay, that's good because I'm thinking now I'm going to just loop from 1 to n. I could loop from 1 to halfway, but the problem is, what is halfway, right? If it's an even number, it's different than when it's an odd number, and I don't want to deal with that, so I'm just going to loop from 1 to n. Okay, so all this between parentheses, I'm going to continue with my procedure. Now I also need an answer. The answer has to be yes or no, or true or false. So I have not, it's not part of the data or the input, so I have to at some point introduce it. And very often when we have a problem like this, we are assuming there's a default value for our answer. And the default value often is that it is true, or no, I shouldn't say that. The default value is what you think. There's no golden rule for to say what the default value is, but it is the value that makes it easiest, let me put it that, make it easiest for you to work with. Of course, sometimes this is only something that we realize in hindsight. So in this case, it will be true, because what I'm going to do is I'm going to go through this list here, right, and comparing the first and last, the second and second last, until I find a mismatch, and then I say, oh, whoa, stop, false. So I'm going to change my mind only when I find a counterexample. So in other words, the default value should be true. Okay, so here we go. So I'm going to erase all this so that it doesn't look like that's part of my pseudocode. Okay, so I declare answer to be true. That's my default value. Now, as I said, we're going to do loop for I going to. So for I, going from 1 to n. Now, I want to point this out. It's very important. I've seen many people in thinking in pseudocode, well, instead of looping from I going to 1, they say from A1 to AN. In other words, they list the input rather than the counter or the index, the subscript. And that's not allowed, right? You cannot loop for A1 to AN because this input will vary, whereas the program has to be programmed and should be input independent. And only when it needs to read an input, it will read an input. If this is something you might have to think a little bit more about, but what it means is that a for loop always should loop over a new counter, or okay, you could have used the counter before for other purposes, but it should not be something that is already being in use. Okay, if it has been used, fine, and it's done with it, then you can reuse it. But if it's in use, you should not use it as a counter. So that's why we use I as a counter here. Okay. And so what am I going to do then? Remember, I have to compare now the ith element. This will tell me how far in the list am I. But remember, we also have to go forward as well as backwards. And we're going to compare those two numbers. Now, a comparison So if they are equal, we are happy and we move on. If they are not equal, then we want to do something. So it's clearly an if-then. If-then, and the only action has to be taken when they are not equal. So it's when they fail. So if AI is not equal to the... Oh, now we have to think about it. What is the I last number? What is the last number is n. So if I is 1, if this is the I, then the I last number should be n, right? If I is 2, then the second last should be n minus 1. If I is 3, then the second last should be I minus 2. So you see that the index of the I last one is n minus I, so is n minus I plus 1. Okay, so it's not n minus, if I would compare a1, I want to, with, if I would not do the plus 1 here, then I would compare a with a n minus 1, right? If I would not have this plus 1 here, and just use the formula n minus I, what you might originally think, then if you check, you see that for I equals 1, it's already the wrong match. I don't want to compare this guy with the penultimate one, I will compare it with the ultimate one, the last one. Okay, so this is the right index, and this is the wrong one. Okay, so sometimes you need to do a little, few examples before you actually exactly know what it is that you want. Okay, again, this is not part of a pseudocode. So if this if they're false, then we know, oh, the answer is false. If this is not, if they are unequal, then it's not a palindrome. So false. And if they're equal, then I'm happy and I move on. So, and when the loop is finished, either this has happened, either this has happened and therefore the answer is false, and it can never be true anymore. Once it made false, there's nothing that makes it true anymore. The only place that the answer was made true was all the way in the beginning. We're not going to return that anymore. So if they found a mismatch, then the answer is false, and otherwise the answer is still true. So at this point I can just say return answer. Now, granted, what you could do is say, okay, once I find a mismatch, there's no reason for me to keep going. So some improvements, if you want, you could, so I'll do them in a different color. I'll do it in red. So one of the improvements I could do is, I could say, oh, at this point I add a return, also red, I guess, return answer. Because at this point here, when I found a final answer, I know it's going to be false, so I can return already. I can stop. It would be more efficient for some cases, but for some cases it might not, because it might be that the last mismatch is at the end of your calculation, so it doesn't make a difference. So that is one improvement you could do. Another improvement that we have discussed is you don't need to loop over the whole word, because then you're actually basically double checking. You're checking everything twice, so to speak. If you're checking K as the first and the penultimate, but also as the fifth and the fifth last one. So you would have checked it twice. That's not necessary. So you could replace n here by n divided by 2, which is not always an integer. So now, should I take the upper or the lower? I think you have to take the ceiling here. Think about it, if n is 5 here, so n is 5, then 5 divided by 2, that is 2.5. How far we have to go? Well, we have to go to 1, 2, 3. So we have to go to the upper, the ceiling. So we have to go to the third letter in this case. So that's another improvement. These are not spectacular improvements. They are make it a bit more efficient. There's a difference in efficiency. This is efficient only in certain cases. In a worst case scenario, it isn't. This is always efficient. So good computer programming would make this happen, but not this. Okay? But I'm not talking about efficient. You might come up with a different thing. Many of you might prefer a while over a for loop. So I will look at all answers that you that you give me if I ask a question like that. Okay, moving on. So let's go to, let's make this black again, and black, okay. No, this is supposed to be gray, right? Okay. Okay, so the next question I want to go to is, another example I want to do is the following. So the problem now is I have two lists, an A list, so A1 up to AN, and a B list. So the input will be two lists, not one list, B1 to BM. And I want to check, is every element of the A list in the B list? In with our sets, if we would say, is the A list contained as a subset in the B list? Okay, so A list and B list are the sets of these elements, and I want to see, are they the same there? Okay, so right, that is what I need to do. Now I'm going to tell you, so do this program using as a sub program linear search. So what I'm trying to say is, you can, well, you don't have to if you don't want to, you can use the linear search algorithm as part of your program. Okay? After all, this is how programming works. Programs are never stand on their own. They use a lot of other programs to do smaller tasks or other tasks. Okay, we will see examples of that also, and so I want to do an example here already like that. Okay, so how would you do that? Well, let's see. I have to check that every element of the A list is in the B list. Well, what do I do? Well, first of all, I have to therefore go to the whole A list. So that's going to be a loop. So loop, so solution, loop through the A list, and search for each list, so A1, A2, etc., and search whether each of these elements are in the B list. I'm formulating that because search, I have an algorithm that does that for me, so I don't have to worry about how do I actually carry out this search. If I want to do this, it's actually much more trickier. So if I don't use this linear search, it gets quite complicated. It gets very subtle, and I don't want to go there. I want to make it easy. So okay, and this is it. This is all what I need to do. And again, if everything works out, then the answer is true. But if I find somehow a mismatch, if one of my searches fails, then the answer is false. Okay, let me not write that up. Okay, so how we do this now? So the procedure, let's call it sublist. Yeah, it supposedly have to be written in cursive. So sublist, let's call that sublist. And so we have A1, AN, and then the second list B1, BM. Okay, there are lists of elements. They don't have to be numbers or letters. They could be anything. Okay, so we have to give an answer that is true or false, and so we should decide what should be that answer be, the default value be. Well, what I'm going to do is searching, and if the search fails, then I'm going to change my mind. In other words, I'm assuming originally, yes, the A list is a sublist of the B list, so answer true. But I'm not saying that's always, the default value should always be true. It just depends on how you approach this. Okay, so I have to loop to the A list. That's a loop. I can do a while loop, but I think I have to go to the whole list anyway, so I'm just going to where did that come from? For. So for I, well, what? Okay, let what now? I need a counter, so again, let's call I the counter. If you want another, you can write counter there instead of I, but it's just a lot of writing. So I equal 1 to n, because that's the length of the first list. Okay. And what I want to do in this counter, I want to now, That's the looping to the A list, okay? And then search whether each of these elements are in the B list. So here we have to carry out a search, and I have to carry out whether the search is true or false. Now, if you look at linear search, the output is actually either 0, which means it's not there, or a number which tells me where it is. Now, I'm not interested in where it is. I'm only want to know, is it in there or not? In other words, is this location, because I think that the variable that you have to go to the textbook, and you see that in the textbook, the linear search uses the variable location. Okay, linear search says location, and if location is 0, then we know that it's not there. And remember, I want to change my mind only when that fails. So exactly that case. So if, now it's an indented if, because I have to carry this out in the loop, because I have to carry this why inside the loop, because I have to do this for every element of the list, of the A list, and that is what my counter exactly makes me do. Okay, so if then, let's think now. So if what? What element am I looking at? Well, the counter I tells me you're looking here at the ith element in your list, that is AI. Okay, so the counter tells me the element AI. Again, don't confuse between the counter, which is a subscript, which is an index, and the element that it refers to. Okay, AI. So if AI is in the list, and that is done by linear search, if the linear search, that's an algorithm of, in linear search we put first the thing that we want to look for, AI. If that's in the list BM, okay, I need a bit more space. So linear search this. Now, we know that the answer here can be two things. It could be a number between 1 and m, which means that AI is in the list, or it could be 0. Now, I'm interested in the last case, if this is 0. Okay, remember the output return is the output is location. It outputs a single value, and that is either true or false. Zero, is either 0 or no. It outputs the location, which is either 0, 1, or m, and 0 is the one that I'm after. So now, because it's 0, because it's not there, I'm saying, oh, answer is false. I have to change my mind. And that's the only thing I need to do. Everything else is now taken care of me. Because if I go, let's see, if I look to this thing, and this never happens, in other words, this never happens, it means, okay, it is a sublist. So at the end, I'm done. And if it's not a sublist, I will find it here, because one of these AIs is not going to occur, so this gives me 0, and I have changed my answer correctly into false. Okay, so return answer. And again, you could here already, once you get this answer false, you could already put a return here. You could already make a copy of this thing and put it here, because you will jump out of it. There's no need to check anymore. But as I said, worst case scenario, when the failure happens at the very last point, then it doesn't save you anything. Okay. Now, if you don't use linear search here, it gets much more trickier, because you have to then keep track. You cannot say just answers true, and once an AI mismatches with the BJ, sure, then the answer should be false. The problem is to keep track of everything else. So if you find an AI that is different from BJ, you know the answer is false. Now, how are you going to make sure that you check everything? You have to think a little bit about it. I'm not saying that it's impossible, but this one is very simple, and I wanted to illustrate that you can use sometimes other procedures. So on a quiz, let's put it this way, whatever has been put in the textbook as an algorithm, or whatever I have discussed in the lectures, not in the homeworks, but in the lectures as a procedure, as an algorithm, you can refer to that algorithm. Okay, let's say it has to be from the textbook, because in the textbook we have documented exactly what the input is or what the outputs are. All right, because sometimes I change this a little bit in the lecture. So you are allowed to do that, although I might not ask that. I'm just saying this, prepare for that as well.